Hey, welcome back from the long holiday weekend, everybody. Hope you had a nice time. Did you see the northern lights? This is a picture I took way up north there, where it's good and dark. Pretty cool. Okay, so here we are into chapter 20 already. How did that happen? A fascinating and complicated structure. The heart. The heart is, of course, mission critical, generating blood pressure, routing blood, ensuring one-way blood flow, and regulating blood supply. Let's talk about each of those in a little bit more detail. The first one is maybe the most important. If you do not have sufficient blood pressure, you cannot push blood through all of the tiny capillaries to feed and nourish your brain and your liver and your kidneys and all of your tissues. Not surprisingly, we see a lot of sick people who suffer from problems from blood pressure, right? If your blood pressure is too low or too high, or too low or too high regionally, just in one limb or in one organ, of course, we can see very serious complications. So it's maybe the most important function of the heart. It starts on day 23 post-conception, starting to twitch and beat and generate a little positive blood pressure. Routing blood, separating the pulmonary and systemic circuits. Look at this image here. You can see clearly that the heart is a single pump in the center of two separate circuits. Look at this. Blood comes into the heart from the body, like the legs and head and neck, and then it goes out to the lungs, and then it comes back to the heart, and then it goes out to the body, up to the brain, down, out to the lungs, and back, out to the kidneys, and back. So you can't focus too much on the color right now, or you might start to get turned around. But here's what I mean. The right side of the heart, shown in blue here, receives blood from the systemic circuit and then sends blood out to the pulmonary. The left side of the heart, shown here in red, receives blood from the pulmonary circuit and then sends it out to the systemic. So what do these colors signify? Well, blue blood is low in oxygen. I call it used blood, right? This blood has flown through or flowed through tiny capillaries. Oxygen has been stripped out of it. Wastes and carbon dioxide have been pumped into it. And so this is used blood. It comes back to the lungs where we get rid of the carbon dioxide and we grab onto the oxygen. Coming in from the air into the blood, it then passes into this left side of the heart and then out. If you watch the next video, I walk you through a lovely animation that'll really make all of this stuff clear. But that's what we mean here by number 2, separating those two circuits. The function of all of our heart valves is the same, really. It is to prevent backflow, ensuring one-way flow of the blood. If we look at this illustration again, you can see what I mean. It's a figure 8 pattern. Blood comes in and goes out. Blood comes in and goes out. Blood comes in. We don't want it backing up or swirling around here. Not only is that inefficient, but swirling and stagnant pools of blood tend to form clots, which can be very serious indeed. Okay, regulating blood supply. You have firsthand experience in this. If you go for a jog, what happens to your heart rate and contraction force? They both go up, right? What happens when you sit down to rest or listen to some quiet music or sleep? The heart rate goes down. The contraction force goes down as well. So later on in the chapter, we'll see how that works and the different mechanisms that help to maintain that sort of supply and demand